Section 2.3 is in the slope of a line. First, the definition. The slope is the measure of the steepness of a line, and so it could be steep or it could be very shallow. To read the slope, imagine traveling across the line from left to right, just like reading. Lines that are increasing from left to right have positive slopes. Lines that are decreasing have negative slopes. Let's highlight for a second. So if those lines are going to be increasing, they have positive slopes. If they're going to be decreasing, they have negative slopes. Then we have two special cases, our horizontal and our vertical lines. Horizontal lines have slope equal to 0, and vertical lines have undefined slopes. Sometimes this is also called no slope. I prefer not to use that term. I don't want no slope to be confused with zero slope, because 0 is a number, there is a slope, and it is 0, as opposed to there not being a slope at all, that being undefined. So I prefer that term. Undefined implies you can't do it, like you can't walk up a wall because it's not possible, I guess. So it's undefined, but you can walk across a floor without picking your feet up. 0 would be the height of your footstep. It doesn't need to be done. You can do it without any slope. There are two methods for finding the slope. The first method is by looking at the ratio, which is a fraction or a division, the ratio of rise to run. That's our first equation for slope. It's the ratio rise divided by run, rise over run. Rise is a vertical distance, so it's vertical change. It's the amount that you go up, and run is horizontal change. The symbol in science for change is delta triangle. So sometimes you'll also see this formula written as delta y, change in y, over delta x, change in x. This is just a different way of saying the same thing. Rise is the change in y being the vertical dimension. Run is the change in x being the horizontal dimension. Something cool. So in the first example, we got a truck driver who has to choose which mountain he will take. Path A has a 20-foot climb for every 150 feet horizontally. So path A, 20-foot climb for 150 feet horizontal, versus path B, which has a 15-foot climb for every 160 feet horizontal. I want to know what the steepness of each of these paths is, so we can help them choose which is the safer route. So in path A, the slope is a measure of steepness, right? Is the fraction rise divided by run. So 20-foot climb, that's the rise, divided by 150 feet run. That's the horizontal distance. Versus path B, which has a slope of 15-foot climb for 160 feet horizontal. I need to grab a calculator real quick. Okay, so with our calculator here, we're going to be able to just get those as decimals. So we're going to start with our 20 divided by 150, so we can compare these. So this slope as a decimal could be written as 0.133, etc. And the other one is 15 divided by 160, so this could be written as 0.094. I was going to go through places again. So the steeper path has the larger slope, so 0.13 is larger than 0.09, so the steeper path, versus the shallower path. Shallower just meaning less steep. And so, assuming that the truck driver would like to take the shallower path, he's going to want pass B. So the truck driver should take pass B because it's less steep. So probably safer for his large truck. All right. Close my calculator, minimize it. All right, so in part 2, I want to find the slope by first determining rise and run. All right, so we think about rise and run as the vertical and horizontal distances. So I make this little triangle here to calculate them. So rise is the amount that you've gone up or down, in this case, from one point to the other. This is a down. So a down is going to be a rise of -2. That would be the rise. I'll label that as rise. Because I've dropped 2 to get from the initial height down to the next height. Then our run is 1, 2, 3. So the slope is -2/3. All right. So when I think about slope, I want to think about the fact that I may have up or down, so I have to make sure I get my sign correct in those as well. Now, just for something interesting to think about, you also could have went the other way and drew your picture this way. It's still the same rectangle, it's just the top sides. Okay, but you still have a run of 3 and a rise of -2. It's just you thought about your run first. I like to think about my rise first because I want rise to go on the top. Doesn't matter which part of the triangle you go for, though. Which part of the, again, it's just 2 triangles, not really a rectangle there. Okay. Now, just referring back to my previous page real quick, we remember that lines that are decreasing should have negative slope, so it's a good thing. This is a decreasing line that our answer was a negative for that one. All right. Method 2 for finding the slope. So if you know the coordinates of 2 points, you can calculate the slope of a line using this formula. The formula is y2 minus y1 over x2 minus x1. Okay? So y2 and y1 are the y coordinates. I'm going to subtract those to find the change in y. x2 and x1 are the x coordinates. I'm going to subtract those to find the change in x. So once again, change is the difference between 2 things, so this is the same thing as what we mentioned on the other side. Change in y divided by change in x. So the 2 formulas aren't different, they're just different per context. Depending on what information you are given to start with, you may want to use one equation versus the other, just context. So 2 methods. So I'm going to use that method for these 2 sets of ordered pairs. So slope, by the way, most of us we'll mention it down below. Most of us use m for slope, so I can make that a note up here, and then I can call slope m. It's just shorter than writing the entire word for slope. Equals, and we'll do the difference of the y's. So when you have 2 ordered pairs, the first ordered pair has coordinates x1 and y1, and the second ordered pair has coordinates x2 and y2. So y2 is the y coordinate of your second ordered pair. So that'll be -6 minus y1 is 4 over second x is 2 minus first x is -2. Watch parentheses when you need them. That gives us a -10 across the numerator, and because that double negative turns that into into 2 plus 2, that gives us 4 across the denominator. It doesn't divide unevenly, but it does reduce by 2, top and bottom, to -5/2. So that's our slope, -5/2. In the part B, we'll try again just calculating the slope here. y2, -24 minus y1 is 10 over x2, -4 minus x1, -4. So that's -4 plus 4 across the bottom, giving us -34 over 0. We can't divide by 0, so that means that m is undefined. If you look back at the first page, what did it mean if m was undefined? If m is undefined, it means that those 2 points must be in a vertical line. They don't have any slope. And so you can go see that those 2 points have the same x coordinate. So they are directly above and below each other. They are going to be part of a vertical line. So we'll just make a note of this. This happens to be vertical. Okay. All right, so example 4. In 1985, the average monthly rate for basic cable was $7.69. In 2008, the average monthly rate was $46.13. Assume a linear relationship, find the average rate of change. The average rate of change is another word for slope. Again, slope is that change we mentioned. So average rate of change, we're just going to translate that and say that that is slope. So the first thing we want to do is write a set of ordered pairs. And I need to let x be years since 1980, so I've got a starting year here. So my first ordered pair, in 1985, we are 5 years since 1980. So the x-coordinate is going to be 5. And the rate was $7.69. And the next ordered pair, 2008, is 28 years since my starting year, 1980. You can just subtract that, 2008 minus 1980, to get 28. And the rate was $46.13. So I have my 2 ordered pairs. Now I want to find the slope, and so I'm going to use y2 minus y1, over x2 minus x1. So my slope, or rate of change, I can use m for that. My slope is 46.13 minus, so y2 minus y1, 7.69 over x2 28 minus x1 5. All right, so I need my calculator here. If I take 46.13 minus 7.69, that gives us, for the numerator, 38.44 over, and then 28 minus 5 is 23. So then I need 38.44 divided by 23, which gives us 1.67. What does the result mean in terms of the situation? It's always the most important part of the question is, what does it mean? Now, slope, rate of change, has y's divided by x's. So if I go back up and look at the units on these, the units on x were years, right? That was years since 1980. And this was dollars. So this was the number of dollars for the monthly rate. So that means that the number of dollars for the monthly rate is the unit across the top. And the unit across the bottom, it's a 1 right now. This is a unit ratio, so it's per 1 year. This is positive, and remember that positive slopes, positive numbers, are increasing. So in my interpretation, I'm going to throw that word in here. Close my calculator. So this means that the monthly cable rate is, so increasing, and I say increasing because the slope is positive. So that's one of the important words. It's increasing by how much? So by $1.67. It's not millions of dollars. I just say dollars. That's the unit on this. It's just dollars. And then I have to throw in the x units. So per, which is a division word. Per is a division word because I've divided by the number of years. So I need to say per year. So all my words here are pretty much essential. First of all, what is it? The monthly cable rate. What is it doing? Increasing by how much? $1.67 per year. tells me a lot. The slope tells me a lot about what's going on here. I knew that it increased by a lot, it looked like. I didn't know, since that was a long time period, what the average change was per year. Now I do. All right, quick summary here about slope. The slope of a non-vertical line. So if we have 2 points in a non-vertical line, the slope is, okay, so we have rise over run was our first definition. We actually were able to change that to change in y over change in x. And then finally we had our formula where we calculated the change in y with y2 minus y1 over x2 minus x1. Now, this does say non-vertical line, although we can use the same information for vertical lines, but it's not going to be a number for your answer. You're going to get undefined. So that's why the definition has that caveat in here. This isn't a value. It's not possible. Defined as the slope, we call it undefined. But you still get to use this formula for any line. Okay? And again, that definition on the bottom, average rate of change is the slope, and then is calculated in a unit of y unit per x unit in change.